Here we go. 2.3, subtraction. Some people say, well, I'm really good at addition. I'm not very good at subtraction. And I say baloney, because if you're good at addition, then you're good at subtraction, because all subtraction is glorified addition. Okay? It really is. Subtraction is just adding the opposite of a number. Okay, subtraction rule. Another way to think about subtracting b from a, just add the opposite of b to a. A minus b is the same thing as a plus the opposite of b. And then it turns into addition, which we did yesterday, which I think people are pretty solid at addition. All subtraction is glorified addition. It's just adding the opposite. So if we looked at 15 minus 7, what's another way to think about 15 minus 7, Stuart?
15 plus.
15 plus negative 7. It's just a different way of thinking of it. And then you could use your rules from yesterday and say, okay, well, if they're different symbols, one's positive and one's negative, big minus small. I wish they'd use a little different example here, but big minus small, okay, 15 minus 7 is 8. Bigger symbol wins, bigger number is positive, so it'd be a positive 8. Okay, that's not the best example to have for that one, but we'll see how that little trick can help us out here in example 1. Negative 10 minus 4. Now again, you can probably visualize that in your heads. You're at negative 10, and you move left 4, where are you going to be? Negative 14. But let's think about it from our addition perspective. Subtracting 4 is the same as adding what?
4.
Yeah, the opposite of 4, negative 4. Now if we think of our rules from yesterday and we say, hey, same symbol, so my answer is going to be negative, and just worry about 10 and 4. What's 10 plus 4?
14.
What's up, Tipka?
Isn't that supposed to be negative 10 plus 4, not negative 4?
Right here?
No.
Here?
There you go.
Well, this is just the opening problem they gave us that we were supposed to solve.
But you said like negative 10, subtract negative 4.
Did I say subtract negative?
Yeah.
I apologize. If I said that, I made a mistake. How about B, 13 minus negative? Kendra, minus negative.
Oh, chop chop.
You really thought I was going to hit you, didn't you?
Yeah.
Conrad's, negative negative.
Chop chop.
Oh, come on, protect yourself. Kimmel, minus negative.
What?
Got to protect yourself. Sather,
Chop chop.
minus negative. Oh my gosh. Minus negative. Yeah, chop chop. Anytime we see minus negative, but again, why can we chop chop?
This is more related.
Why can we chop chop? Julia?
Because 2 is 100.
Yeah, if we, remember, subtraction is like adding what? Shower?
Yeah.
Subtracting this is like adding the opposite of this. What's the opposite of this? Positive 11. Oh, so that's where the chop chop comes from. Anytime I have two negatives next to each other, boom, boom, chop chop, we've got 24. All right, let's jump to example 2. Now we get into algebra. All algebra is glorified mathematics with variables thrown in there. Okay, we're supposed to evaluate the expression a minus b plus 5.3 if a is 6.5 and b is negative 3. Okay, well what should I substitute for a? Yeah, exactly what they told me, 6.5. So take 6.5, substitute it in for a. What do I substitute in for b?
5.3.
No.
They tell me b is negative 3, so I'm going to substitute b in for negative 3 in for b. Logan, I see a minus negative. What do I need to do?
Chop chop.
Chop chop, right there. Minus negative, chop chop. So 6.5 plus 3 is?
6.5 plus 3.
9.5.
You got 6.5 plus 3. You're right, 9.5 plus 5.3 is going to give us?
14.8.
14.8. Okay, change in subtraction into addition makes things a lot easier. All right, let's have you guys try checkpoint problems number 1 and 2. When you think you got them, raise your hands. Akehurst, I saw that hand fly up. What do you got for number 1? Yeah, negative 12. Now, we're going to run through a real common mistake. In fact, I saw it out of 4 or 5 people here. I saw a lot, not a lot, but I saw at least 4 or 5 people say the answer was 12 because they said, well, 4 and 8 makes 12, and you've got a negative negative, so you need to chop chop. What's the only time you can chop chop?
There's a negative.
Can.
If a negative is next to a negative.
The negatives have to be next to each other, or it could be, you know, like that. Okay, but you have to have 2 consecutive negative symbols in order to chop chop into a positive. We can think of minus 8 as glorified addition. It's negative 4 plus the opposite of 8. Well, if we use our addition rules from yesterday, same symbol, add the numbers, 4 and 8 makes 12. They're both negative, so my answer becomes negative 12. Who's got number 2? 9 minus 18. Conrad's?
Negative 9.
Negative 9. Very good. You think of it as adding the opposite. 9 plus negative 18. We talked about our rules yesterday. Take big number minus small number. 18 is the big number. This is a small number. 18 minus 9 is 9. Bigger symbol wins. The bigger symbol was negative, so our answer becomes negative. Okay? And after you do these enough times, you're just going to be able to pop them off that quick. Okay? You'll visualize that number line in your head. All right, let's jump to checkpoint problems 3 and 4. Try those ones when you think you've got them. Holy cow. I can't even keep up with you guys. Okay, taking a look at checkpoints 3 and 4.
Stop talking.
Señoritas, ¿estás listo? Sí. Okay, if we look at, whenever you evaluate the expression, you're plugging values in. Good habit to get into is to plug them in, show that you've plugged them in, just kind of use parentheses, group what you've plugged in. Taishana, what do you think for number 3?
It's 3.2 minus negative 4.
So you got 3.2 was M, minus for T, she plugged in a negative 4, plus 2. Taishana, what do you got to do when you have minus negative? Chop it to a positive. So 3.2 plus 4 makes 7.2, plus the 2 gave you your final answer of 9.2. Very good. Somebody out with 4. Tipka.
Well, M is going to be 3.2,
Yep.
subtract 3, which is 0.2, and then plus negative 4.
Yeah, because if you minus a T, if you minus T, but T is negative 4, again we have to chop chop, so we get 4.2. All right. Last idea here, this idea of change. A sign at the start of a hiking trail states you're 320 feet below sea level. At the end of the trail, another sign states you're 880 feet above sea level. Find the change in elevation of the trail. Okay, so you got to imagine, here's the ocean. I think you guys have seen my artistic skills before, haven't you? There's the ocean, there's the beach, there's the hotels. Haven't I showed you this picture before? Yeah, here's the valley, here's the mountain. You start 320 feet below sea level, you're beneath the sea, and the sign at the end of the trail says you're 880 feet above sea level, and you're supposed to find how much change there was. Okay, first thing I want you to think about, did you go up or down? Up. Went up. Okay, because sometimes when people are working this problem, they'll say, oh, well I went from here to here, or they'll say I went from 320 to 880, so the difference, they'll go 320 minus 880. But if you take 320 minus 880, you're going to get a, what kind of number? Negative, which implies you went down. Okay, so we have to have a common way to define change. Over in the margin, please write this. Change equals new minus old. Okay, whenever you want to find the change of something, you have to take the new value minus the old. So in this case, we're going to take the elevation at the end of the trail minus the elevation at the start of the trail. What was the elevation at the end of the trail? 880. What was the elevation at the beginning of the trail?
Negative 320.
Very good, doll. It's not 320 because you're below sea level. That would be like a negative number. Negative, negative, we need to chop chop to a plus. So 880 plus 320 gives us 1,200.
Gordon said it's bad to chop.
She said it's...
Mrs. Gordon told us to do leave, change, change. It was never chop, chop.
She
used
said
to make
it's
fun
bad
of
to chop because it'll not stay in your fridge for a long time.
And she used to make fun of it.
She said it's kiddish.
If I hit you hard enough, chop you hard enough, dude, it'll stay.
I'm gonna tell
Trust
Mrs.
me.
Gordon that you're making us do chop chop.
Tipka.
Can't you just like do the absolute value of 320 and then add it to 84?
You could, in this case, that would work, but it might not always work that way. Okay, real quick, try checkpoint problem number 5. In the morning,
Oh, I finished that one.
Wake up in the morning feeling.
Mr. Hilliard, you correct me.
okay, in the morning the temperature was -3, in the afternoon it was 21. Find the change in temperature. All right, gang, in number 5 here, what's the new temperature? Because change is defined as new minus old. Riley, what's the new temperature?
24.
Careful, what's in the information given, what's the new temperature?
Oh, the new temperature is 21.
Okay, now we subtract the old temperature, which was -3. We chop, chop. Now, a lot of people had this for their answer.
It's not right.
Okay?
It's degrees
24 hamburgers.
Now, I try not to be an average teacher, and I don't want you guys to be average students. I want you to be above average. Okay? Miss Jansen, you ready? If we leave our answer as 24, we're leaving it open to a lot of interpretation. Is that 24 millimeters? Is it 24 seconds? What should I throw on there?
Degrees Fahrenheit.
Degrees Fahrenheit. We always want to label in a real world situation. Okay, the people who didn't label the South St. Paul Bridge, when they mislabeled how much concrete mix they were mixing with something else, they built the whole bridge and they messed it up, so they had to build it again. That was like a $20-some million mistake.
Did they really?
Because they didn't label properly.
Did it actually happen?
Yes, it did. Can you believe that?
Is that, wait, is that the...
Okay, my last question for you guys, little theoretical. Notice we didn't have any properties today. We didn't have a commutative property of subtraction, something like A minus B equals B minus A. Can somebody tell me why there is no commutative property of subtraction? Nye.
Because you would get a totally different answer.
Get totally different answer. 5 minus 3
And it's property of addition.
is not equal to 3 minus 5. Okay, we don't have those properties with subtraction because subtraction is a little different when you're operating than addition, okay? Yes, sir.
I just noticed that isn't it kind of like the opposite?